Hey guys. So today we're going to talk coordinate systems quick, and I want to start this with a little bit of calisthenics. So I'd like you to think about a point in the middle of your chest, right? So right in here, and stick your right arm out to the side. So I now have my right arm out. This direction, I'm going to think of as right. Big surprise. This is probably backwards for you because you're watching the video. Now I'm going to stick my left arm straight out in front of me. So this I'm going to think of as forward. And then I'm going to think about my head. And that's up, right? So we've got right, forward, and up. And those are the three directions that we're going to use to describe how points are in space, right? We're going to say how far are they to the right, how far are they forward, and how far are they up. In our kind of mathy world, we decide to obfuscate that a little bit, make it confusing. So my right is going to be the X direction, my forward is going to be Y, and up is going to be Z. It doesn't really matter how you kind of stick this thing into space, right? We're just going to keep those coordinates, right? So the important thing is going to be that X act like your right arm and the Y act like your left arm and the Z act like your head. That gets a little complicated, so most people use their hand. So for our hand, right, we're going to do, put your hand in this funky little configuration. So this is my right hand. And I've got X goes that way, Y goes this way, and Z goes up. We're going to draw this in a variety of ways, but it's going to be important that we keep that right hand rule. That's just so we agree with physics. It doesn't actually matter in the world. Like, you could formulate math with kind of upside down Z's and it would be totally fine. To keep things straight with physics, we're going to go with that right hand rule. So let me draw a couple little pictures here. So, and actually, I'm going to start with not drawing a picture. I'm going to start with looking at a little graph that I've made. So this is a product called Math 3D. We're going to use this a lot through the semester. So it'd behoove you to get good at this. What I can see on my little picture here is I can see that I've got a point. That's this orange guy up here. That's got coordinates that are A, B, and C. And you can see that A, B, and C are given by my sliders. So that's the over part, right? The first coordinate, the X, is going to be 1. The forward part, right? So I'm thinking over 1, forward by 2, and up by 3 gets me to my little orange dot up there. That's at 1, 2, 3. And we can see that if we kind of change one of these things, we'd have maybe a different point, right? So this is our point that's now at 2 over, 2 back, 3 up. So that would be the point 2, 2, 3. Math 3D uses these little brackets. I'm going to tend not to use little brackets. When I describe a point like that, I'm going to describe it like this. I'm going to describe it with parentheses, X, Y, and Z. And these are going to be what are called rectangular coordinates. So a couple of notational things, some stuff that I tend to do just for you guys. I tend to make these little thought bubbles. Those little thought bubbles are saying, I'm looking at this and I'm thinking something. They're not necessarily a quality. They're sometimes just motivation or vocabulary. In this case, they're vocabulary, so I might throw some quotes around them. I'm going to drop some axes in here. So here are some axes generated by OneNote. And I didn't like the way those look. What I'm trying to get here is a nice aesthetically pleasing picture. And I find that if you make that exactly 45 degrees, it's not actually aesthetically pleasing. So you want to make it slightly different. So here I've got my over is my x-axis, back is my y, and up is my z. And of course, we could go left. We would just describe that with negatives, right? We'd say we wanted to go back 1, or sorry, left 1, back 1, down 1. we could describe that. It's just fine. It'd be the point -1, -1, -1. And we could go back to our little Desmos or our little Math 3D guy, and we could actually input something like that, right? If we make all of the variables negative, we'll see that we're going left, back, and down, as opposed to something where we had some kind of mix where we might go left and forward and down. You can see that doing this, there are kind of 8 places that I can get to here. Those 8 places that I can get to here are called the octants. And they're 1 through 8. So I'm going to number them here real quick. It's going to get a little tough. So I'm going to actually kind of cheat. I'm going to go like this. I'm going to draw a little, actually, I'm going to generate that because I have this tool. So I'm going to generate this little XY plane, right? So I've got X this way, Y this way. This should put Z sticking out straight towards you. So in the positive Z side of this, right? So sticking straight up. So these are things above the XY plane. These are going to be quadrants or octants 1, 2, 3, and 4 per usual, right? So that's this one up here is 1, this one back here is 2, this one back or towards us is 3, and this one here is 4. And then we're going to go around the bottom. So we're going to copy this whole picture. And we're going to change a couple of things. So we're going to change this to, this is now in the negative Z's, but we're going to count the same way. So we're going to go, oops, yeah, good. Okay, so we're going to go, this would be 5, 6, 7, and 8. And I promise this is the only time I'm using Roman numerals. And I'm not honestly going to care about these most of the time. The one we're going to talk about the most is the first octant. So every once in a while in a textbook, they'll say, hey, the chunk of this shape that's in the first octant. And then you just have to know that they're talking about this octant 1 where everything's positive. You guys can make up some little mnemonics for these if you want. I don't think you super need them. Just remember, you count like usual, and you start with positive, and then do the negative ones. Okay, so a couple other things. I said these are called axes. That's usual notation, so I figure you guys are used to that one. This little dot here in the middle, that'd be the point 0, 0, 0. That's going to be important. We're going to call that something special. I'm sure you guys have heard this word before. That's going to be called the origin. And then I think our last thing we need to learn about is the distance formula. So how to tell how far apart 2 points are. And for that, I'm going to go to a little Math 3D sketch again. So give me 1 second. So here I have a little Math 3D guy. I've got my 2 points. I've labeled them A and B. You can see that I've given them some coordinates. So A is the same point we were looking at before. It's 1 to the right, 2 back, 3 up. And pause the video, spend 2 seconds telling me how to get to B. Okay, awesome. That's going to be left 2, forward 1, up 1. Okay, so let's talk about getting between those 2 points. So here's a vector, which we haven't covered yet, but trust me, it's just a line. So I've got this little line that's connecting my point A and B, right? Now I'm interested in how long is that line. So here's a trick. The Pythagorean theorem still works. It just has this problem that it has to be applied in right triangles. And I'm not really quite seeing a right triangle here. See that? So what I'm going to do is I'm going to think about the steps that I would do to get from A to B. So to get from A to B, in the X's, I need to go down 3, right? So that's going to be an arrow pointing to the left 3. You see how that gets me from the X coordinate of A to the X coordinate of B, right? if I, oops, I can't cock my view. You guys see that? So from the x coordinate of A to the x coordinate of B. We're not to the point actually, because we have 3 directions. We need to get all 3 of them to agree. So our next step is going to be, we look at this and we say, okay, in the y's, we need to go from 2 down to 1. So that's going to be, we need to apply a -1 in the kind of y direction. So that's, it needs to come towards me, right, out of the screen 1. So there's my kind of over. And now here's a right triangle. Boom, right triangle. I can apply the Pythagorean theorem to that right triangle. What that's going to do is that's going to let me draw another vector. So if I think about going from this height down to B, I just need to adjust. I need to go down 2 in the z. So bam, there's down 2 in the z, and there's another right triangle. So I'm going to write down the formula. I want you guys to actually go figure this out. So I really encourage you to build 3 sides of a little box out of paper, and then find those right triangles that I've just drawn in there. You can do this. It's not that hard. So I want you to do that on your own. Build me a little paper box. And the result that we're going to get from that is going to be this thing called the distance formula. And I'm going to write it down right here. So the distance formula. Okay, and the distance formula is going to be, so I'm going to add a little assumption here. We're going to go from a point that's x1, comma, y1, comma, z1 to another point that's going to be x2, comma, y2, comma, z2. Oops, let's try for a 2 there, huh? And if you can't read this, I'm going to, after every single one of these, convert all this to LaTeX at least as much as I can, and I'll dump this PDF. There will be a link to it in the video description. There will also be a link to it in the Canvas module if you're actually in the course. So we're going the distance between these 2 points, and the way we're going to establish that is we're going to say that it's the square root. So we're going to say d is equal to the square root, and here we're going to do the distance we had to go in the x direction squared. So that's going to be this guy minus that guy, plus the distance we had to go in the y. So that's going to be y2 minus y1 squared, plus the distance we had to go in the z. So that's going to be z2 minus z1 and also squared. Okay, so that looks a lot like the Pythagorean theorem. In fact, if we kind of covered up this part, it would be the distance formula from R2. So I want you guys to build your little box out of paper and convince yourself that this is true. Because I can tell you it all day long, but I think you should convince yourself that it's true because it's hella cool. A thing we get out of this for free is something kind of rad. Out of this for free, we get the equation of a sphere. And I'm going to give this thing a, so of radius r centered at h comma k comma l. Okay, so I'm thinking about that this way. So I'm drawing my little circle, right? So this is how Joe draws spheres. Hey, that ain't bad. Got a sight. Okay. Come on. Just had to make the little nick in there. Okay, so I've got the center of my sphere. Center of sphere is here. And point on the boundary is up here. And the thing that I know about spheres is that the distance here has to be r, right? And this point in the middle, oops, that's supposed to be an arrow. is h comma k comma l. Okay, so what do I know about points on the boundary? I know they're all are from the middle. So I could write this down in what's called the kind of rhetorical math style. I could write a sphere is all points that are from h comma k comma l, right? That'd be enough to describe a sphere. That's a description. I can turn that into an equation by just writing down what this means. So that r from this point means that the distance from any point to HKL is r. So if I write that down, I'm saying the distance from any point, so that's going to be the distance from that point to h comma k comma l is going to be given by applying the distance formula to an arbitrary point, x, y, z, and that center point. So I'm saying here, I've got a quantity that's the distance. So this is distance from arbitrary point to HKL. And I'm going to set that equal to R. And then if I square both sides, which boy howdy is a lot easier here when you can copy and paste. So I'm just going to take that exact same equation. Why it showed up over there, I don't know. And we're going to erase our big old square root guy and square the other side. So I got from here to there by squaring both sides. This is the thing I'm going to tend to do. I'll draw a little arrow from step to step. That's just me saying, what did I do? And this is a picture of a square. So I squared both sides. That's how I got to this equation. So I'm going to have another video that's a little demo on how to get Math3D to draw something like this. But for right now, this is what I need you guys to take. So this is coordinates in a nutshell. These specifically are rectangular coordinates. We're going to talk about some other coordinate options later. In fact, you already know one, so you might spend a second thinking about what the one you already know is. See if you can expand that to 3D. That would be cool to talk about. Thanks, guys.